All right. All right. Everybody's funneling into the group. Fantastic. We'll let everybody slowly start to funnel. So thank you, everybody, for making time to join our weekly webinar here at BEEC. We're always very happy to have our Director of Education, Peter Alexander, to illuminate some important topics for us. Today, we have a very exciting topic, but I'll let everybody slowly funnel in until maybe perhaps another minute. All right. So this is an extremely important topic because there's this concept of computers and STEM as being strictly for those interested in math and science. But as the world perhaps develops, we call this beyond STEAM, as in STEAM has become a very critical, we would say, catchphrase for curriculum and development of students over time. But in fact, the way that STEAM is helping students to prepare for what we call a computer literacy is perhaps not meeting all the demands of students. So that's why we call today's topic Beyond STEAM, Computers and Your Future. So I think perhaps now is the time we can turn it over to Peter. But before we do, we always like to introduce, for those of us in the audience who know of us, great. For those of us who do not, we always like to say a little bit about who BEC is. All right. So BEC, we focus on the long-term development of students. That means if we're helping students to prepare for and apply to college, which we also do high school, we do master's apps, but let's say if we're helping students prepare for and apply to college, then what is the eventual goal of this process? The eventual goal is you will graduate and you will do something beyond college. So if we can help students better understand what that future goal is, then we believe we can help students to make better plans, more focused, and with better results, so that students can achieve their short-term goals of getting into a great school by focusing more on the long-term goal of what they're trying to achieve after school. In this way, students can have a stronger purpose for why they're studying, and they can have better plans that support it and greater motivation to achieve that longer-term goal. And in the process, become the kind of students that colleges want. Because by the time that these students apply, they have a strong vision for themselves. They have a strong background related to the thing that they're interested in. So this is very, very important for us. And I think at this point, I can turn it over to Peter.
Oh, great. Thank you, Jonathan. I really appreciate the opportunity to speak on this topic. It's certainly Absolutely. A favorite of mine. And yeah, you mentioned purpose. And one of the things I think that comes up, one of the reasons why we wanted to talk about this subject in terms of STEAM. So just by way of review, that stands for science, technology, engineering, arts. I believe that's the A.
It is the A.
And then mathematics. And so when we have an acronym like that, it's supposed to have a purpose, I guess, right? And that's science, technology, engineering, arts, mathematics. Doesn't that sort of include everything? So why do we even need I guess maybe it doesn't include basketball, right? Or
I think it excludes the sports, but basically is very comprehensive besides that.
Right. Well, anyway, so the purpose of tonight's talk is to really explore some of the ways that the computer literacy affects us, both through the educational process, how it shapes the paths and the decisions that we're able to make. And let me just go over tonight's topics a little bit briefly here. So we're going to talk about computer literacy, what it is, and why it's important. We will examine the issue of the relationship between computer literacy and computer science. Some people might just think this is another word for computer science, and we'll address that issue. Computer literacy and the classroom. If you are familiar with the Common Core, impact on the purpose of an education, then you would see that computer literacy is stated as part of the Common Core requirements. And so we're going to explore a little bit about where they are in that process. I'm going to have a little bit on how you can actually be a technical whiz and still actually be computationally illiterate.
Right. I think that may be one of the more interesting points. There's this idea that you can know what you're doing with computers, but be actually inept when it comes to actual computational literacy. So I think that exploration will be interesting to kind of define what that means.
Yeah, and some of the implications. So we'll be exploring some of that as well with that. And then, of course, I'm not just going to state a problem. I'm also going to make some suggestions about how you can pursue paths toward that solution. What you're not going to hear tonight is discussions of conditional for loops or recursion or anything like that. What I do hope to leave you with is a sense of appropriateness of the kinds of things that you should be looking for, some tools that you could appropriate when you are searching for computational solutions to problems, even in business or in education.
Great.
Okay, so before I actually define computer literacy, I kind of want to just approach the subject in terms of what does a computer literate person look like? Well, they don't necessarily look like a computer, but maybe you might think that they are a brain in science and in mathematics. They're really great with numbers. They might be great at video games. Maybe they're a hacker. You might think that they are really great at hacking into other people's computers and doing weird things like broadcasting the latest reruns of, I don't know, Law and Order. Maybe they might be a video game whiz. I think I might mention that earlier. They might be at, I don't know how many levels of Doom or whatever video games. I don't play video games, so I don't know about that. But they might be very, very advanced at that. Or maybe they're a Googler. Maybe just, that could be, oh, you work at Google. You must be great with computers.
Peter, if you don't mind me, we have one person in the audience saying, does it mean a coder?
Well, certainly we're going to be talking about that
We'll get there.
a little bit later. Yeah, just because you code, does that mean you are computer literate?
Right.
And I'm going to say no to all of these things. Computer literacy involves some of each of these, but it is a lot more comprehensive than.
I think I am none of those besides Googler. I am a Googler. Well, Google as in I use Google, not Googler as in I work for Google.
Right. Okay. So a computer literate person, just some basics about them. We're still talking a little bit about them. Well, they're not afraid of the computer. When they get behind a computer, they certainly are not afraid of making mistakes. They're not afraid of crashing a program. They're not afraid even necessarily of breaking hardware.
I'm afraid of all of those things.
and I certainly am, when it comes to using Microsoft software, I certainly am a little bit afraid. I'll have a little bit more to say about that later. But they know how to use the internet, not how to use the internet to get the latest on the weather or using Yelp, but they know how to use the internet to find answers to important questions that have to do with their technology. And getting at that, they also understand the limits of computer solutions. They really have a keen sense of when a computer can be actually adapted to a specific type of problem, either in business or in industry, education, and so on. And when the kind of problem is of such a nature that it does not admit a good computer solution. Mostly, they can think and speak algorithmically, and that's really a big thing I want to focus on tonight. The role of algorithmic thinking and learning and speaking and representation in all of the areas of computer literacy. So algorithmic, we'll talk a little bit more about what algorithms are in a moment. But this is probably one of the most important aspects of what differentiates just someone who knows how to code, knows about computers, from someone who can actually, who we would say is computer literate.
Right. Well, I really love that phrase, literacy. It reminds me of fluency. Just like in a language, where if you're truly fluent, it means you understand each angle, that you really have not just understanding of what the words mean, but you have a cultural understanding. And the same thing goes for computers. It's not just, oh, I know how to use this app, or I can, tell you 1, 2, 3, but really it's, even if something goes wrong, well, you can even identify perhaps what went wrong.
Yeah, I think you're speaking exactly to toward the end of my talk, Jonathan. I don't know.
I'm skipping. Sorry.
But it is really the computers and computation has become a social phenomena.
Right.
And we'll talk a bit more about that later and the importance of that. And so, yes, computer literacy intentionally, I think, is supposed to remind us of fluency. That's exactly the point. I think that's exactly the point. That's right. And so algorithms, so if computer literacy and fluency in some sense go together, the concept of algorithm plays sort of the role of the language in which computer discussion, computer analysis of problem-solving situations, it's motivated by the perspective of the concept of an algorithm. And so an algorithm I'm calling here, it really is the art of procedural knowledge. And I call it an art because I really believe that it is an art to coming up with good algorithms. So not logarithms. Sometimes people who have had a little bit of math get algorithms confused with logarithms. Really, the easiest definition of an algorithm is it's a set of clearly defined instructions to perform a specific task. The two key words here are clear and specific. Okay, clear and specific. And I'm going to demonstrate that a little bit. In mathematics, the idea of algorithm is closely related to the notion of a function. If people who are in math classes or recently had math classes, you probably understand a little bit about what I'm talking about. The function concept is a set of procedures.
Right.
So here's my little example, and I love giving this in programming classes. It's so simple, but it can really illustrate a very good point. So we want to make a peanut butter and jelly sandwich, and we have an image in our minds about what this means. And so this next set of instructions is really actually an algorithm, and it's sort of an average over hundreds of students' responses. So they usually start off something like this. You take 2 pieces of bread. You put peanut butter on one and jelly on the other. You put the coated pieces together. Done. And when I have this picture here in mind, I look at this explanation. It looks pretty clear. Okay. Now, the problem, though, is that there are other interpretations.
Deconstructed peanut butter and jelly.
This is the deconstructed peanut butter. You see, here we have our 2 pieces of bread. We have peanut butter on one of the pieces and jelly on the other. And I don't know what this other stuff is here, but so this right here, although it is an algorithm, it really allows for the production of many, many different kinds of things that don't look at all like this. So the idea of an algorithm being precise is a set of ideas or set of instructions which will actually lead to what it is that we were intending. And so good and bad algorithms in a sense reflect good and bad thinking. And good and bad thinking turns up really in the grocery store all the time. If we buy junk food, usually junk food goes into our bodies and we can have problems. If we buy good food and we know what to shop for, then we wind up being a little bit more healthy. And the same thing actually is true when it comes to the world of software. I think that a good measure of excellence is the software's usefulness. Algorithms, good algorithms, turn into useful applications, and useful applications reflect good algorithms. And if you are used to thinking about things algorithmically, you will be able to discern what are actually good and bad applications that you might be looking for. So they force us, when we have to think in algorithms, they force us to think about hidden assumptions. For example, in the previous example there, the assumption that the pieces of bread were slices. That's an example of a hidden assumption. Hidden assumptions are all throughout our problem-solving situations. Forcing ourselves to think algorithmically helps us unlock hidden difficulties of a problem. And it's good training for software shopping. When we are trained in how to approach our own problems that we might want to apply a computer to, if we know exactly what the problems are, we are much better at becoming shoppers for things that we actually need, and instead of filling our carts with many things that might look interesting but might not necessarily be useful.
I think, Pete, I think that's such a good point, in that a lot of times, at all ages, we're looking at software and we're looking really at what they're promoting as their capabilities, or what are the results, or show us a demo. And anyway, we're often missing or unaware of what's driving the software and what are the principles that make good software, versus seeing, what are the typical end results. And although typical end results are important, it's a not complete evaluation of what makes good software.
That's right. That's exactly right. The ends, in some sense, that the software was intended does not necessarily mean that it's. I'll have a little bit more to say too. Things like how much memory the software uses, and so on. So let's define computer literacy. And for many of you that I've invited, I said that our host, a key guest that we would have would be Winnie the Pooh, and so he's going to help us along through the rest of our talk.
He's our very politically sensitive assistant, but no politics were meant to get involved here.
That's right. He knows a little bit about these things, and so I think he has a little bit to say, both what to do and what not to do. So it's a commanding power of language, which equips us with the capacity for each of these things. Analogical reasoning, probably one of the most important factors in learning, is being able to learn and use analogies to take what we know and assimilate what we don't know. That's called analogical reasoning. The next aspect is procedural explication. It's one thing to explain a process. It's another to explicate it and to expand on it and to really understand the specifics of what the solution is actually doing, how it's affecting you, the consumer, how it affects the machine that you're putting the software on, in a very clear and thorough, in a very clear and thorough manner. So procedural explication is people who are computer literate can explain these kinds of things. It provides a capacity for temperate evaluation. So you understand what is appropriate, what are appropriate lengths that the technology can actually be used, and ordinate judgment. So what kind of application is correct for what kind of solution, or for what kind of desired problem? What kind of solutions are you looking for? And many times Pooh has come up with many solutions that actually turned out to be disasters. And if anybody remembers this story, this was one of them. So the computationally illiterate, let me contrast a little bit. They're often stuck in a language rut. They don't have the language to begin to even describe the kinds of problems that they're having, that they think that they can use the computer for. But they have a general vague sense that they could use a computer to solve a problem. Mm-hmm. So they have a difficult time communicating both their needs and what they actually know. Many people do actually know what it is that they know what the problem is. They just have a problem actually using language to communicate that. And so these types of people have a very difficult time even talking to someone in the computer science industry or within the computer or information technology industry, because they don't know how to talk to these people.
Sure. Yeah, Peter, if you don't mind, I'll interject. We had we just helped him to apply to master's, but we had a very qualified, highly intelligent student at UC San Diego, computer science. Very brilliant, all A's. And he was about to do his interviews for an internship. And we were going over potential questions. And we were going over some of the typical questions that an internship, supervisor may ask. And they were not challenging questions. Simply how some of the technology worked in this kind of project or in this kind of scenario. What would you choose and why? And it was very difficult for him to respond. And he knew what to do. The answers were, you would say, correct. But in terms of why, explain it. Explain it to someone who's not in your department of why to do this. It was really beyond him. And this was really challenging for him. And he was, 21 years old and getting all A's in all of his classes at UCSD. So when you're speaking about literacy, yeah, you can be a whiz, but still be somewhat illiterate. And, was this process really helpful for him? It was huge. It helped him to connect with his coworkers, with his supervisor, everything. But until he was forced to be in this situation, the curriculum itself, even really strong, UCSD computer science curriculum, didn't prepare him for this kind of literacy.
Mm-hmm. Yeah, and I think that I don't want to associate, some sort of judgment.
Right.
It's fine if you're computationally illiterate. Sometimes this becomes more difficult to people like that. It's a good point. Good point of bringing
this absolutely this up. Crushed him in terms of getting into. Said, imagine, and seriously, in some of the interviews they say, hey, imagine this is a 10-year-old. How do you explain it?
Exactly.
And they want to test your communication ability.
Yes.
And he said, well, how could I explain to a 10-year-old? I said, that's what they ask you. You don't have to know why. The point is, they want to know if you can. He said, well, maybe I cannot. I said, well, that's going to be a bad answer. You're going to fail that question. So anyway, he got over it and he started digging deeper into it, but he's getting there. Yeah,
that's great. See, my mom just turned 91. And see, my mom would never have a problem admitting that she's computationally illiterate. It really is. I know one person who graduated from UC Berkeley in computer science and was not able to answer some fundamental questions that I asked when I was interviewing for some Python programmers about a year ago. And so this is really something for them that it's hard for them. And so as I elaborate a bit more on this, keep in mind that this is really something that we all have to go through at some point if we intend to actually become computationally literate. But I just want to discuss some of the drawbacks of staying illiterate. So they tend to be easily amused or impressed with what amounts to little gizmos that aren't necessarily useful. And the software comes with frills and things that and bells and whistles, and yet the computationally illiterate are sold on these kinds of things, and yet the software doesn't solve the problem that they actually are trying to solve. they are, another one of the drawbacks is they can be easy prey for tricksters. What happens is for a jar of honey, what do they get? They get your credit card number, they get social security numbers, they get driver's license numbers, they get your birthday, they get your friend's email. So all sorts of things that come to you. In most of the destructive email campaigns, phishing campaigns, are successful with people that just don't know much about computation, about when they should be opening up emails. This just actually happened to my mom about 8 months ago. And she had her identity stolen, and we had to close her bank account. And so being not necessarily being aware of what you should be paying attention to can really get you into some unfortunate circumstances. This is probably one of the most important areas I think I want to draw some attention to. I have this little chart here, evaluation of the design, okay, of products, of computer products, software solutions. That's what we're talking here. So I'm talking about the evaluation of the design. And here I have the idea of the orientation toward the product itself, the orientation toward the product's promise. And what do you think about the user experience failure, for example, okay? And so the computationally literate and the computationally illiterate, they react very differently. And so let's just go through this. When the product fails, I get a piece of software and it fails, someone who's actually computationally literate understands that's typical. Software breaks down and you got to learn how to fix it. You got to learn where to look. You got to learn who to ask. Of course, it's not ideal and no software developer likes that, but that is just part of software development. Even products that have been released, even after they've passed their beta phase, we always will buy something and something doesn't work. And computationally literate people understand that that's just part of the experience. The computationally illiterate are thrown into crisis mode. What do I do? Oh my goodness, I got to take my computer to the Genius Bar at Apple, or I've got to take it to Central Computers, or I've got to call up the Geek Squad or something. Now in COVID, what do? There's no one to go to. So you're really in a bad situation here. What about the product's promise? So the product, Microsoft has a new release of a new operating system, and it's supposed to even cook your evening meal for you. It will run to the store for you. The computationally literate are genuinely pretty skeptical about what is actually promised. The computationally illiterate actually look to, oh, thank goodness, I will never have to do blah again. I will never have to operate that in batch mode again. And then that often turns into a feedback loop, because when it fails, they go back into crisis. When you have the user experience using the software, a computationally literate person looks at it. If it doesn't work, I look at this. If I can't figure out a piece of, if you don't get anything from this discussion tonight, take this away. If you can't, we are now in the day, in an age where design is so crucial and so highly refined that if you have a product that you can't figure out how to more or less get some use out of in a few minutes, it's their fault. It's their fault. It's not yours. We have the capacity to design user-friendly apps. And if you look at our website, the way I've designed it, I just got the biggest pat on the back the other day from one of our staff. They said, wow, it's really user-friendly. Absolutely.
Our BEEC Go is our student platform that we are developing, but luckily, yeah, it is quite user-friendly, and we've seen some great results with it. Yes, keep going.
Yeah, but the computationally illiterate, they look at it as their fault. Oh, what did I do?
Right.
You know, I didn't read all the instructions, and where's the manual? Where's the 40 software used to come with 300-page manuals, depending upon how much it did. There's no manuals anymore. It's designed to be user-friendly. And we're at the stage now where as you become computationally more literate, you'll see it's the designer's fault. Microsoft.
Yes.
Okay, so let's move on here. So you were saying about that student. I have a little anecdote that I want to talk about from my own personal experience in mathematical finance back in trading. I was doing some engineering of a model, and I was actually developing the trading platform, and I was the research person managing the risk, and the portfolio manager was, in some sense, he was one of these people that knew how to use some of the software that he had, but really did not understand how software and computer models were involved in trading. And so my research indicated that portfolio models were absolutely essential to strong trading results. This is how all professional trading operations actually secure the kinds of returns that they do when the markets are performing well. His response was, it's of marginal use. He was what was called a technical analyst, in the sense that he looked at charts and graphs and tried to draw meaningful conclusions from those. And so he looked at the charts and the graphs, and a lot of the software that he had told him information, gave him information about that. And so he didn't understand that how the research and the mathematical models for portfolio were important. Predictive analytics, this comes from big data and from data science. My model was accurate, my predictions were accurate to within about 5%. And he was always questioning them. Regardless of what my models would predict, he wouldn't go with it because it just didn't follow with what his intuition was. Well, at the end of the year, the yearly return, my predicted results would have been 30, and if he would have followed it, I had the historical record, and the simulations going back on the historical record, we would have concluded the 2007 trading year, if any of you remember back that far. Was a great year. Hodge's fund, for example, was around 35 or 36% return on that year. They're a huge hedge fund. This would have been a very, very good year, probably pretty typical for most professional trading groups, but his portfolio was only 26, which actually was poor for that year. And so his illiterate insistency, because he wasn't going to listen, actually lost an enormous amount of money for his clients. Even though they were up, they could have been up a lot more, and we actually did get many complaints on that. I'm no longer working with him. At the end, his concluding remarks were, and this was my decision to part company with him. He said, "How can you do all that? It can't be that easy." Well, what he didn't understand is that I had about $50,000 to $60,000 of proprietary software that I was using on loan from Stanford's computing facility. And so it wasn't all that easy. I also had over 6 years of education in quantitative finance. And so none of the models that I was working with or developed were in any way easy. And they were the kinds of things that you usually pay between $30,000 to $50,000 a month for Bloomberg to deliver you. And so his ignorance really, this was a statement of that kind of thing. My conclusion, I guess, is that computational illiteracy almost always has contempt for, or can lead to, contempt for creativity. It doesn't like complexity, has no sensitivity to the complexity of certain kinds of problems. And it's not sensitive to caution. This is one of the reasons why my mom, thinking that she was going to win a prize, opened up an email and started filling in all sorts of information. And it's almost always impressed by image and what seems to be intelligence, and imprudence, not paying attention to what would be appropriate in a certain kind of problem-solving situation. Thinking that one solution can work for basically anything. On the other hand, in contrast to that, computational literacy, again, often, not always, but it collaborates with creativity. It embraces complexity. It is very, very concerned about making too many moves too quickly. And we really ignore people's images, whether they got a degree from UC Berkeley in computer science, what they say their IQ is, and no matter how much they brag about themselves, it's really not very important to people who understand a little bit about how these things are put together. Again, I'm probably not saying all that much about things that people don't necessarily already know, but just underlining some of these. The computationally illiterate almost always, this is a very important point, they almost drastically underestimate the costs of value-added computer solutions, because they don't understand just what it takes to implement an information technology solution well. They tend to think that it's really easy and that it can be done overnight. And so they tend to make poor decisions around these kinds of issues. I actually I'll say a little bit, I was guilty of this once myself. I had just recently got an internship for a data science company, modeling the performance of RFID technology. And I got very angry at the IT team because they didn't show up at 7 o'clock when they were supposed to meet me. And the person, the CTO, said, do not talk like that. Do not think like that. This is IT, and they were delayed, and they had some problems, and that's just the way it is. And I was put in my place. I just didn't understand what the other kinds of problems that they were working on, and how and the significance of the other things that they were doing. So they tend to drastically, also on the other hand, they overestimate the usefulness and applicability of computer solutions. So sometimes computer solutions have a certain range of applicability, and beyond that, it's not. You need some other solution, or you can't use a computer. And the computationally illiterate often are a bit misled where that boundary is. So about computer science, we were talking about this. So isn't this just taken care of by a good computer science program? And this is a great book. It's called Pooh's Wishful Thinking.
Integral reading for computer science.
Integral reading for the state of our school systems with regard to computer science. And I'll just leave something with you. Why would a good computer programmer, a sound computer programmer, want to work in the public school system other than they just believe in a noble cause? The computer programmers, good computer programmers here, make between 150 and 300,000. I'm sorry, 150 and 300 an hour, working as software engineers, and there's no way that they would be interested most of the time. And it's very, very rare that you find people who are strong programmers with good computer sense who actually take up jobs in the public school system, unfortunately. So this book maybe would be useful for people in administrative roles. The answer is no. This stuff is not addressed in computer science. Let me show you here a little bit about what the role of computer science in computational literacy. So we have computer literacy itself, knowing about computers and knowing about hardware and their structure, knowing about systems and applications of systems to solve problems in business, industry, and in education. We have the role of language that we use to describe computer applications and problems to which computers can be applied. We have the idea of problem solving itself, methods of solving problems, Certain methods work for certain kinds of problems and not for others, and understanding how to make clear distinctions is incredibly important. And this is how software engineering, good software engineering this is how good software engineers do their work. And all of these inform computer science, which then informs computer literacy. And you see, so this is all a kind of, it's a cycle. Except for the computer science part, if you can take off the computer science here, we all have experience with all of these other things. Computer literacy, we know about computers, we talk about computers, we have iPads, we have iPhones, we all talk in languages, we all have to solve problems, we all use software. So literacy can actually begin even before and certainly long after courses in computer science. So computer science is a small aspect of computer literacy, and it's not necessarily even a required part of computer literacy. It helps, but again, it's not necessarily something that needs to be required. So the computationally literate understand machines. You were talking about this a little bit earlier toward the beginning, Jonathan. They understand machines as a social phenomena. And the idea is that
we're back.
What's that?
I think it was unstable for a minute. You were frozen for a minute, but you're back.
Okay, we see now. Okay, great.
Yeah.
So I was getting to the idea that this is a social phenomena. And we're all using Facebook, we all use Twitter, we're using the computers as part of our social life. Now with COVID, computers and programs and software is an integral part of how we're staying even connected. And computer science really is computer science itself is still in the early stages of understanding the implications of what's going on here. Talking a little bit about schools and computational literacy. Is this addressed by Common Core? Well, so you might think that your kids are in a computer skills class, and there are actually computer skills classes. And we would like to know, what are they learning? Well, they're learning about keyboarding, and they might be learning about different apps, perhaps, that they can use. But unfortunately, in the public school system, and what is called computer literacy in the public school system is really only marginally related to genuine computer literacy that I'm talking about here. So what we can rely on the public school systems largely to do, they can comply with administrative pressures. They oftentimes, especially now in the COVID-19, they sort of do the bare minimum with the students, getting them to learn some keyboarding skills, learn how to use the printers, learn how to perhaps use the internet a little bit for reports. But they aren't really teaching our kids more than they already know using home computing experiences. So in some sense, all Common Core really is it's sort of authenticating or underlining things that people are often already doing. And in many ways, what they do is, because you've taken this class, you now think oftentimes that you are you have something in the way of computer literacy, and in some sense it can be more of a curse than than useful. And so this is sort of getting at the idea of how you can be a tech whiz and not necessarily know about these other areas, these more important areas of literacy in computational circles. So the idea is that knowing other people's software solutions does not necessarily help you with literacy. So for example, students might know many languages, many computer languages. They might know Python, they might know Java, they might know Node.js, to some popular ones, HTML. But they really don't understand the purpose for a specific language. So for example, when would you use a Python implementation over a Java implementation? Well, these are very serious and deep questions. And many people, many graduates from computer science in computer science majors don't understand how to answer these, because these aren't even being addressed at the university level. So for example, you might want to get lots of likes on your Facebook page. Do you understand what that is costing you in terms of your visibility to the internet? Do you understand the risks that you are running at exposing the kinds of content that you put up there with regard to its history, how long it's going to be there, who can see it, what they can get, what kind of information they can get about you from the kinds of things that you might be doing just with your friends, not even thinking about the overall implications. And the other idea is many swipes, no swindles. Well, the more you swipe your credit card, the more likely it is that you could have, you could be a victim of identity theft. And that's a very simple example, but the more you actually use the internet socially, the more consequences are there for people to see what you've been doing and what your history is. And if they are so inclined, they can put you into some situations that you might not find too favorable. So some of the things I want to say is, here's some questions that you should be able to, you should think about learning how to ask and answer when you're thinking about software solutions. So in the role of someone who is computer literate, is the app that you're going to download, is it really applicable? So understanding what problem am I trying to solve here? And is this app really for it? I wanted an app for just the other day. I just wanted an app that has a nice big clock on it. And I tried downloading this free thing, and there it showed up in the left corner of my screen, and I had to spend more than 5 seconds figuring it out. I said, forget it. So the kind of razor-sharp decision-making process, don't mess around with things that, first of all, know the problem that you want to solve, and don't mess around with stuff that isn't solving your problem. The other thing is, how much time will you actually save? Do you know how much time a computer solution will actually save you? You might be able to get around actually having to adapt a computer solution to your situation. It could be that I still use the old-fashioned notebook and pen because I found Microsoft's notebook or OneNote to be actually miserable. What kind of exposure? I just indicated that a little bit. What kind of exposure will you have? So if running this app is you're going to run an app, and if it's related to the internet, what kind of exposure are you running? What kind of risks are you running in actually using it? What kind of information might you be exposing to everybody? And this next one is a really good one. I think is the apparent need for this software solution, does it come from within you, or is it something that you're getting as pressure from other people? Is it something that you realize could be a solution to a problem that you have, or is this something that you're feeling this general vague sense that you should be using a computer more effectively here to solve this problem? You can save an awful lot of money and an awful lot of time if you think carefully along those lines. This next question is a little bit like that. Is this need, does it emerge from a series of problems that you're presently having, or are you just trying to be more tech savvy and use a computer to enhance the technology that you're implementing as part of your business, or as part of or your classroom or something like that, or whatever it is that you're using the computer for? And again, I think I talked about this. Can you get the gist of what the software solution is in 5 minutes or less? This is a really good, if you can't, it's probably not designed very well. Application software, immediate application software that we're going to be using daily should be really pretty easy to use. I'm not saying that you could become an expert, but really it doesn't take much more than 5 minutes to 10 minutes for people to get up and using things like PowerPoint and doing some things with it. And so you really want to look at this as a criterion for selecting software solutions. So if you've tried all of these kinds of things, what can you do then? There is information technology mentorship and coaching. Actually, BEEC does offer this. And this is now an emerging kind of service that just like life coaching or organizational coaching, information technology mentorship and coaching. Yeah, you want to say something, Jonathan?
Yeah, well, I was going to say the idea is that, we have a lot of students all over who are pursuing the study of different computing languages on their own or with us. But no matter what, they're trying to achieve things by learning those languages. That means accomplish projects or, somehow apply their skills to something real. Otherwise, what's the point of having the skill? So in this way, they often need to expand their knowledge base or have a consideration of how to accomplish a project from different angles that maybe they couldn't do on their own or would just be way too time intensive on their own. And we can actually help them to accomplish the projects or better fine tune how they are approaching their technical skill, accumulation of knowledge to better execute these awesome projects that they're trying to achieve. Otherwise, they hit roadblocks and it can be difficult and they might quit or they might change their direction when in fact it was a solvable problem. They just didn't have the guidance along the way.
That's exactly right. Yeah, we are in an age now, in an information explosion right now. And the last thing that you want to have to do in order to use an enterprise, I didn't talk much about this, I'll use the term right now, enterprise software. Now this is something, these are not apps, but you might need to use enterprise software. You might need to use a business level, corporate level implementation of Microsoft Excel or something. And you don't want to take a 6-month course at a community college learning how to get up to speed with what your company is doing. And so these kinds of services are exactly appropriate for these kinds of things. You don't want to have to go to the library and pick up a book and spend hours and hours pouring through information you don't need to know to get to information that you do need to know. We live in a top-down world now. Long ago past has been the time when you start from the ground up and learn this stuff. Application-specific support desks are often available in big enterprise level deployments, for example, with Zoom or with Adobe and so on. So learning how to make use. And again, this is part of computer literacy, getting used to and learning how to access some of this information. Application-specific user groups are often there. This is even more so the case. I didn't talk about that. Maybe we'll have another webinar on the whole open source community. Is actually a really wonderful community if you can become part of it. I mean, open source, that's software you don't pay for. It's stuff that people develop and make freely available to everybody. Linux operating systems are examples of that. Application-specific user groups there are just enormously helpful, and they can really educate you quite quickly on specifics of what you need. And then there's information technology and application software consultants that actually come alongside and look at your business needs, and help you decide on what kind of appropriate software solutions are available to you. And the last, I think, is if you have friends in similar situations. Sometimes we're embarrassed to just not talk about it. We don't want to admit that we have this thing that we can't do, but sometimes talking to your friends about it, sometimes they're often more than willing to help. And that's another reason I really like the open source community. Is it's really a lot of friends helping other friends navigate the complexities of of the software industry and the information technology world that we live in. And so I think that's about it. Well, just in conclusion, so for all age groups, I wanted to say, you don't just have to be in school, or you can be at any age thinking about this, but also for younger kids especially, now's the time to think about preparing for computer literacy. That means not just learning about video games, not just learning about how to move stuff around using some fun kind of programming blocks, but actually learning how to think algorithmically, exploring what algorithms are. As parents, there's lots of games out there that are very useful teaching tools. If you're students and young professionals and you think that you are comfortable with technology and you're just great with Facebook and and Instagram and so on, really, I think that you should be careful. You should be careful with what you know. Maybe what you know might be masking some grave problems that could be coming your way concerning things that you don't know. I would be really, really suspicious about what you don't know. Especially for people who know programming languages. Do you understand the more global perspectives where computer programming now fits into our society as a whole? And for others who are feeling like they're missing out, so I just would say, listen to the wisdom that you actually have gathered from various coincidences. It's a line from a Bob Dylan song, but I think it's really true. When something is given us with all sorts of bells and whistles and it seems like it's too good to be true, or even, and we can't figure it out, and I think that just going back to perhaps, is this really something that we need? Is this really something that's going to take more time, even though it's going to be a technical solution, or less time? And just going back to some of our own sound wisdom, and looking at okay, well, this might be not the best implementation, but it works, and just trusting ourselves for and our trusting our own judgment. And I think that's it. I think that's all
well, thank you so much, Peter. I know this was a big topic and perhaps a lot to digest, but it frames the next step, which is the idea that approaching computer science as strictly a study of facts, like you would in a school, like you would in a class, is not going to be enough. Because if you want to create projects of your own, if you want to pursue your own sorts of, whether it's an app, whether it's another way that you want to apply your computer skills to what you're trying to accomplish in school or an extracurricular activity, then you're going to hit roadblocks, and you can become a better developer, a better problem solver with this literacy. And that the way it's currently being taught in schools, we, once again, we see students that are doing fantastically in terms of their grades, but the moment they begin applying the skills into their actual life, into their projects with friends or on their own, they're running into all sorts of issues. And sometimes the issues are actually quite easy to get past, but they take some perspective. So that's something that's really important for us, because we're all about making sure that students can achieve their goals, can reach for higher goals, and that means a lot of doing. Learning is part, but learning for the sake of doing. So we just wanted to really hammer down that point, and we're really thankful for everybody for listening. And once again, we love to throw up the Yelp because we're still at 5 stars. Maybe if it changes, we'll forget, skip it. But for now, we are still 5 stars. So we thank everybody, our students, our parents, everybody, and we can go into the last slide, I think. And for those who do want to contact us, we always welcome it. We're available all the time. Feel free to email us. Feel free to add our WeChat account. We're always around, just trying to get in touch with more students to help out. So yeah, thank you, everybody. Thank you, Peter. I believe that is about it. If we have any questions in the audience, of course, we'd love to take them. But otherwise, yeah, it was, thank you everybody, and thank you for the time. Okay.
Do we have it? So I don't see the.
Oh, it's okay. I'm monitoring, and we do not. We'll give everybody perhaps a few more seconds to chime in, if they do, because we always appreciate the questions. But obviously, we're always happy to answer those questions privately too. You know, whether that's through WeChat account, whether that's through email. Sometimes, you know, that's preferable. We understand. But either way, yeah, thank you guys so much. And perhaps, yeah, we will call it a night then. Okay.
Okay. So let me stop the share.
Yeah, so thank you. Okay. Bye-bye.
Okay.